We are talking about polynomial long division today. This is going to be not as difficult as you might think at first. So the best way to start something like this is by remembering how we used to do it with integers, with numbers. So if I had a problem like this down here where I was supposed to take 5,391 and I divided it by 13, then before we all had calculators, we knew how to use long division. Let's have a look and remind ourselves. The first thing is that I can rewrite this as a fraction. 5,391 over 13. Now, this one on the top is the dividend. This one on the bottom is the divisor. And this is going to be all equal to, once I have divided 13 inside into the quotient, and possibly a remainder over the divisor. So there will we will have some left over, some remainder, maybe it will be just 0. So how to do this is by performing the following. I set this up as a long division problem. 13 divided into 5,391. This down here, let's make the arrow a little bit nicer. This right here is called the divisor. This down here is the dividend, the thing that you are dividing. And this up here will be the quotient. And let's have a look what else happens. So, how to do this? Well, I am going to look at 13 and I ask myself, does 13 go into 5? Clearly not. Does 13 go into 53? Absolutely. How often does it go in there at most? Well, let's have a quick look. 1 times 13, well, that's 13. 2 times 13, well, that's 26. 3 times 13, well, one moment, that's going to be 39. 4 times 13, all right, that's going to be, let's have a look, 40 plus, that's going to be 52. Whoops, 4 times is the most amount of time that 13 goes into 53. So I have a 4 right here. Now the next thing that we are doing is I take this part of the quotient and I multiply it with all of the divisor and I will place this underneath here. So what is 4 times 13? Well, that was 52 as we have seen. And what we are doing now, I'm going to place parentheses around this number and I subtract this from the top. 53 minus 52, that will be 1. Now there is still something to bring down from my dividend. There is a 9. And I'm doing the same thing as just a second ago. 13 goes how often into 19? Well, 1 time at most. 1 times 13, place it underneath here. 1 times 13, place it underneath there. What will we get? Well, 1 times 13 is 13. So you always divide and then you multiply. You divide and then you multiply. You divide, you multiply, and then you subtract. 19 minus 13, that will be 6. There is still something that you can bring down from the dividend, that is the digit 1. The 10th unit, so to speak. And I do the same thing as before. 13 goes how often into 61? Let's have a look. Does it go in there 5 times maybe? 5 times 30, that would be 65. No, that is too much. So it goes at most 4 times into it. And as before, 4 times 13 goes underneath here. You put the parentheses around it and then you subtract. Let's have a look. 4 times, let's keep the colors right. That was 52. And now I am going to subtract this. Let's get rid of those arrows right here that I have placed there temporarily. So I subtract 52. 61 minus 52. Let's have a look. That would be 8. That would be 9. So now I look, and 13 does not go into 19 anymore. This down here is our remainder. So, in other words, 13 was not a perfect factor of 5,391. There was a little bit left over. And if I write this whole now down in the same way as right here, well, then I will get this result. That 5,391 divided by 13 was equal to 414, the quotient, plus a little bit extra. It is a little bit less than 1. It is the remainder divided by the, that wasn't 3, that was 9. The remainder divided by the divisor. And we are now going to do the same thing with polynomials, the construct with the variables in them. So let's go ahead and do one. We want to take 8x to the third plus 5x squared plus 7x plus 2 and want to divide it by x plus 2. So the first thing that I'm going to be doing is I rewrite this as a fraction. X cubed plus 5x squared plus 7x plus 2 divided by x plus 2. What will this be? Well, I know already how I'm supposed to write down my answer. It will be a quotient plus a possible remainder divided by the divisor. Well, the divisor, I know already what it is. It's x plus 2. I just need to find out what I have to place in here and here. All right, so how do we do this? Well, we are using long division, and for that matter, I need to rewrite my problem. I am placing my x plus 2 to the left, and underneath this long line, I will put my dividend, which is x cubed plus 5x squared plus 7x plus 2. Now, one note, we need to make sure that there is a spot for every exponent term, so to speak. So for every degree. 3, 2, 1, x to the first power, and the last one is the constant. Now I'm doing the exact same thing as before. I am taking, the only difference here now is that in my divisor, the only thing that I will consider at first is the biggest one, the biggest degree term. And in this case, that would be x to the first. And I will only ask myself, how often does it go into the biggest one over here, which is x to the third, 1x to the third. So let's write down the steps in great details. The first step, step A, is going to include two things. Step 1, I'm taking the x cubed, the biggest one from my dividend, and I'm dividing this by the biggest one from the divisor. X cubed divided by x. Well, let's have a look. That is going to be something that we have done in the last section. That's just x squared. So in other words, x divided into, how often does x go into x cubed? 1x squared times. I probably should better move this all just a slight little bit down. It's called long division for a reason. So what was the step now with the numbers? Well, after this, I'm taking this and I multiply it with the whole divisor, the quotient multiplied by the divisor, and I will place it underneath here. I will put parentheses around it, and then I will subtract. Let's do exactly just that. So in my step 2, the second step now. I will take the x squared and I will now multiply it with all of the divisor, x plus 2. And what is it that we are going to get this way? X squared times x is x cubed. X squared times 2 is plus 2x squared. So, over here, one more time. First, how often does x go into x cubed? X squared times. Now take this part of the quotient, multiply it with everything over here, and place it underneath it. And that was x cubed plus 2x squared. Let's clean this up a little bit. Now, in the next step, I take all of this and I will now subtract it from the top. So x cubed minus 1x cubed, that is going away. Positive 5x squared minus a positive 2x squared is a positive 3x squared. You have to be careful about the signs here. All right, that was the end of iteration 1. And iteration is just one time going through something. The next thing that I have to do, just like with the numbers, there is still something up there that I can bring down, positive 7x. And now I'm just going to do the exact same thing as before. I'll do this a second time. I'm starting with my x, and I ask myself, how often does x go into 3x squared? How do I find this out? By taking 3x squared and I divide it by x. All right? And 3x squared divided by 1x, that's going to be 3x. So plus 3x is the next part of your quotient. And in my second step, I'm going to take this again, multiply it with all of x plus 2, and write it underneath the 3x squared plus 7x. So in my second step now, I'll do exactly the same thing as I did before. 3x, I multiply this all with the divisor x plus 2, and that will give us 3x squared plus 6x. All of this right here now is going to go underneath here. What am I going to do next? I subtract this from the top. Let's make the colors match. 3x squared minus 3x squared goes away. 7x minus 6x, that will leave us with exactly 1x. And I'll do it again. First step, x goes how often into x? Hold on, there's the 2 that I can still bring down. X go how often into x? Well, x divided by x, what is this equal to? Well, this is exactly 1. Plus 1. Now I'm going to do exactly what we have done the last 2 times. The second part of my third step is going to be take the x, the 1, and multiply it with all of the divisor x plus 2. And we are getting 1 times x plus 2, of course, just x plus 2. And just like before, I will place the x plus 2 underneath here, put parentheses around it, and subtract it from the top. And I see that x minus x is 0. 2 minus 2 is also 0. And that means that the remainder was actually 0. Now what this means for this overall problem is actually really, really important. that means that I can first fill in my blanks here. I now know what these question marks were. The quotient is x squared plus 3x plus 1. And the remainder was 0. And that means that 0 divided by x plus 2, of course, is just 0. That means now in hindsight that x plus 2 actually was a factor of this long polynomial up here that I did not know before. All right, let's do another one. Maybe this time we can skip those steps written down on the right side so that it doesn't look more complicated than it really has to be. All right, I have 8x squared plus 6x minus 12, and I'm supposed to divide this by 2x plus 3. I wonder what this will be. How do I do this? By setting up a long division problem. 2x plus 3, the divisor goes to the left, the dividend goes underneath, 6x minus 12. And now I am starting this in the following way. 2x goes how often into 8x squared? So in other words, 8x squared divided by 2x. 8 divided by 2 is 4. X squared divided by x is x. Now I take 4x and I multiply it with the divisor right here, and I write it underneath here. And I will get 4x times 2x, that's 8x squared. 4x times 3, that is positive 12x. What I have to do now, I have to subtract this from the top. So, divide, multiply, subtract. Divide, multiply, subtract in this order. In this next step, I just have to be a little bit careful. 8x squared minus 8x squared goes away. 6x minus a positive 12x. A quick reminder. Positive 6x minus a positive 12x. Well, this is 6x minus 12x, and of course that is a negative 6x. I still have something that I can bring down, the negative 12. And now I just start this over again. Negative 6x divided by 2x is negative 3. Negative 3 multiplied with all of the divisor, negative 3 times 2x is a negative 6x. Negative 3 times positive 3 is a negative 9. I place the parentheses, I subtract this from the top, and I get negative 6x minus a negative 6x goes away. Negative 12 minus a negative 12. That is nothing else but negative 12 plus 9. Negative 12 minus a negative 9 is negative 12 plus 9, and that is just negative 3. And we have a remainder. So, that means now that 8x squared plus 6x minus 12 divided by 2x plus 3 is equal to the quotient for x minus 3 plus the remainder negative 3 divided by 2x plus 3. Now, of course, this can be written as 4x minus 3, and this negative sign in my numerator can just come and jump up front. So in other words, I have minus 3 divided by 2x plus 3. How could I check this? Let's do one last thing in this section. We want to see whether or not we did this right. So we had 8x squared. Oh my goodness. Let me just copy this right here. Let me copy the whole answer right here like this. So I want to see whether or not I did this right. And there is a way for us to do such thing. So right here was the problem. So what I'm going to be doing right now is the same thing as if I would ask myself, let's have a look. Here's a silly one. 12 divided by 5. Well, that is going to be 2 plus 2 over 5. There's a remainder of 2 divided by the divisor. I can check this by multiplying both sides by 5. If I would multiply this side by 5, and if I would multiply this side by 5, then I have that 12 has to be equal to 5 times 2 plus, well, over here the 5 cancels out, just 2. And that is, of course, 10 plus 2, which is 12. I'm going to do the same thing over here. It has to be then that 8x squared plus 6x minus 12 has to be equal to all of this on the left side, 4x minus 3 divided by 2x plus 3 times 2x plus 3. So I will take this now and I will first multiply it with the first binomial, and then I will multiply it with this. And what I have is 4x minus 3 times 2x plus 3 minus, well, this 2x3 will cancel out. I just have minus 3. I am going to practice now my chapter from before, multiplication of polynomials. 2x times 4x, that would be 8x squared. 4x times 3, that would be 12x. Negative 3 times 2x, that would be negative 6x. Negative 3 times positive 9, it would be negative 9, minus 3. And if I now combine like terms, I have 8x squared plus 6x minus 12. All right, let's have a look. Now, this is exactly what we were supposed to have.